Okay, everyone, let's go to example number 2 to practice function continuity. Look at this function. This function, for the x's equal or smaller than -1, this is how it looks like. And for the x's bigger than -1, this is how it looks like, and this is the whole function. So let's find out if first of all, if it's continuous or not. First of all, the f of -1 includes here, because -1 equal or smaller, so it includes the equal to -1 is here. So this would be the function, would be x squared minus 3 when we put -1 in it, so it would be -1 squared minus 3, which will be 1 minus 3, which is actually -2. So the f of -1, the amount of f of -1 would be -2. And now let's find the limits. Let's find the limit of f -1 for the x's is smaller than -1. So the left limit would be, again, for the x's is smaller, I will use this one. So it would be limit of x squared minus 3 when x goes to -1. From the left side, of course, it would be again -1 to the power of 2 minus 3. So the answer would be -2. Interestingly, it ends up being equal to the amount. And now let's look at the right side. Oops, sorry, I should have written fx here. Fx of limit of fx if x goes to -1 from the left side. And in here, limit of fx if x goes to -1 from the right side. From the right side is actually limit of, because if x is going from -1 from the right side, it's x is bigger than -1. Therefore it will be dealing with x is bigger than -1, so this function is involved, limit of x minus 1 when x goes to -1 from the right side, which will be actually -1 minus 1, which is -2. Interestingly, look, they are equal. So the left limit ends up being equal to right limit. Therefore I can say that the limit, so fx, if x goes to -1 from left side, equals the limit of fx if x goes to -1 from right side. So the limit, therefore the limit exists. Okay, this condition is met. And then the other condition, first of all, I can see that the f of -1 is defined. The function is defined in the point -1 because it exists in here. So the other condition is gone. And also the f of -1, the amount of f of -1 in the point -1 equals to the limit. So the limit of fx when x goes to -1 ends up being equal to f of -1. So therefore this function is continuous. The function is continuous. So now let's just check it in the graph. You guys, I suggest you to draw your, just give numbers to x's and find the y's and draw your graph. But because we don't have time right now, I do it quickly, but you yourself be patient and do it. So for the f of -1, I know that my point would be actually -2. Yeah, so this is where my point is. And for the smaller than -1, I'm dealing with this function, which is kind of a curved looking like this. And for the this is for smaller than -1. For the bigger than -1, I actually have a line, as you can see, which is going to look like this, a line. It's a line actually. So as you can see, this function, even though it changes direction, it changes its shape, is a curve in here and it's a line in here, and it also changes direction, but it is continuous at this point. There is no separation at this point. There is no break at this point. There is no hole at this point. So I can see that the function is actually continuous. We can analyze it in the function too. As you can see, first of all, the f of -1 is obviously equal to -2. And then going towards the -1 from the left side, the limit of fx, when we go to the -1 from left side, from a smaller x's, I will have, of course, -2. It ends up being -2. And when I go to this side also, because in here I deal with this, right? And when I go in here from the right side, limit of fx, when x goes to -1 from the right side, is also associated with this movement, which is associated with this movement, so it goes to -2 again. So I keep from both sides. If I go here, I go here and I go to -2. If I go here, I go here, I go to -2. So in both cases, I go to end up going to -2. All of this is equal, so the function is continuous.